Hello, good morning, class. First of all, I will introduce myself. My name is Raisya Nasywa Ayuningtyas Wibowo. People calls me Raisya. You can call me Miss Raisya. I'm 20 years old. I'm originally from Depok, West Java, but I currently live in a boarding house in Malang, East Java. I'm a student studying at the Department of Physics, State University of Malang, and I'm also a new physics teacher in this school now. I'm from a family of five. My family consists of myself, my parents, and my older and younger brother. My hobbies are playing basketballs and badminton. My friend described me as a thoughtful, optimistic, and positive person who give the support for around. Okay, class, how are you today? I hope you are all in good condition because lately the weather is been very cold. So stay warm, everyone. We are back in the physics class. Do you remember what topics you studied at the previous meeting? Great job, class. In this morning, we will learn a topic about movement dynamics in the subtopics of Newton's first law. To start the lesson, I have a question for you, class. Have you ever ridden a bus or car that move a constant speed and then you are very comfortable sitting in the chair? However, suddenly the driver brake. What happened to your body? Maybe anybody that want to answer my question? Okay, if nobody cannot answer my question, I will appoint one of you class. Sorry, what's your name? Okay, Doni. Please answer my question. Good job, Doni. Is there anyone that still have a question from Doni's answer? If there is not anyone want to asking, all of you can open physics book on page 98. First, we will learn about Newton's first law of motion. You can see in the page 98. Okay, class. Newton's first law presents that a body will not start moving until and unless an external force acts on it. Once it is set in motion, it will not stop or change its velocity until and unless some force acts upon it once more. The first law of motion is sometimes also known as the law of inertia. There are two conditions in Newton's first law. First, when an object is at rest, velocity and acceleration are zero. Therefore, the object continues to be at rest. Second, when an object is in motion, velocity is not equal to zero, while acceleration is equal to zero. Therefore, the object will continue to be in motion with constant velocity and the same direction. I mentioned external force earlier. Do you know what they are? An external force is defined as the change in the mechanical energy that is either the kinetic energy or the potential energy in an object. These four are caused by external agents. Example of external force are friction, normal force, and air resistance. Until here, are there any question? If not, I will explain about the application of Newton's first law in everyday life. One of the application is wearing a seat belt in a car while driving. If an accident occurs or brakes are applied to the car suddenly, the body will tend to continue its inertia and move forward, probably proving fatal. To prevent such accident, seat belts are used. stopping your body from moving forward in inertia and avoiding danger. If there is a block at risk, what the force on the block? The only force acting on the block are the force and gravity and the normal reaction by the surface. There is no force acting on it in the horizontal direction. Since the force in the vertical direction are equal to each other in magnitude, they cancel each other out and hence there is no external force on the block. Since this block is at rest, we can say that it confirms Newton's first law of motion. When we pull a paper with a coin on it very quickly, the coin will not be pulled along with the paper, but will remain in its original place, in accordance with the sound of the Newton's first law. An object that is at rest well remain at rest if the resultant force acting is equal to zero. Objects that are pushed will stop on their own because they are influenced by the Earth's gravity. In addition, the force generated by a non-slip plane or friction force will reduce the force on objects moving on a raw plane. This is why be pushed object will stop on its own. Next, this is running. At the moment of starting a runner experiences air resistance that is smaller than the thrust, so the runner can accelerate. So remember, every object will continue to be at rest or moving at a fixed speed along a straight path if it's not forced to change its state of motion by force acting. Is there anyone to ask? Okay, if not, we have reached the end of the lesson. I would like to ask you stand next to your table, and each row takes turns to come forward in a circle. Come on, first row, please. Okay, I'm going to give you a topic about today's lesson, and you say one to two words that define the topic. First row, ready? The first topic is equilibrium. Please, say one to two words about equilibrium. Good job, class. Next row, your topic is zero force resultant. Please, say one of two words about zero force resultant. Good job, class. Okay, I think you have understood today's material very well. Give a round of applause first for you. Okay, class, thank you for following the lesson well. I think that's all for today. Thank you for your attention. See you next time, class.